Hell yeah. Oh, I think we're streaming, everyone. Me. Okay. Hello, people. Hey.
What?
Hey, Tad G Star. Hello. How well can I actually be? How well can I be heard right now? That is the question. Let me fix my chat.
No,
You can hear me?
No.
No, you said no?
No, I can.
Oh, you can. Hi, everyone. Hello. It's maths time, basically. Oh, I keep trying to push my chair forward, realizing I'm running into a wall of sorts. So, actually, wait. Let me do it like this. I'm going to pull this down. I'm going to pull this up. Ooh. Okay. Hello, people. Welcome. Oh, 30 likes already. Thank you. Hello. Thank you. G'day, people. We're doing maths. I believe, what's the title of this? Specialist Maths Masterclass. That is what this is going to be. I mean, look at this question. That's absolutely beautiful. Absolutely beautiful. Let me move my... I'm going to move my things around just a little bit. That way I can see everything that I need to see. How's everyone doing tonight? Hope the answer is that we're doing good. I feel like... No, it's probably... It feels... For me, it feels like I'm echoing a little bit. Hopefully, you guys can't hear the echo. Does it sound like an echo to you? I don't know. I feel like I'm... My voice is bouncing. Did it sound like that when you were listening? Yeah, I'm sure it's fine. Yeah, you can go. Just close the door. Love you. Alright. Okay. Sorry, everyone. Wait, I'm temporarily... Emphasis on temporarily. Blocked from seeing the chat whilst I get all my windows correctly open. Hi. Hello. If people want me to wave, there's a wave. I assume you guys can all see me wave. That's good. I'm just... Look, there's quite a lot of things that I have going on, right? Because I need to have, like, a visible chat. That's one thing. Okay? There we go. I think everything's lined up. But then I also want to be able to see what I look like to make sure that I'm writing actually on the screen. So we have, like, 7 things we have to try to get ready. Oh, yeah, I've got my glasses on. I don't always do my stream with my glasses on, but we got glasses on for today. Okay. You know... Yeah, I think I can see everything, but the only thing I can't see is if there's anyone actually... Oh, thank you, Olov, for the rose. I can't see if there's anyone actually watching. That is my only issue, is that I have no idea... Maybe it's a good thing I have no idea how many people are actually in the stream. Maybe I can look on my phone, too, and just have, like, massive overstimulation. Maybe I can't. Oh. No, that's myself. Can I view my own live on my own phone? Oh. Oh, I can. Whoops. Wait, so can I see? Oh, I can kind of see what's going on. Okay. Well, we're in like massive overstimulation mode. So my phone here, I've got my iPad, which I'm going to be writing on. I've got the sort of chat in front of me. Oh, okay. Wow. Okay, we actually got questions. Is this methods or spec? This is specialist maths, hence why it is an integration by parts question. Integration by parts being, of course, in specialist maths. There's 35. Oh, thank you very much, Dill. Spec maths. Hello. Say 6, 7. I'm going to avoid that for now. But thank you guys that have joined. Thank you, Nia, for sharing the live as well. If you know people that do specialist maths, feel free to share the live with them. Yes, this is Year 12 Specialist. This is the 2020 external exam, because that is what I had. And we started this during the last live. Okay, this is where we left off during the last live. We looked at vector equations. We spoke about vector equations of planes. We spoke about normal vectors, all that stuff. If you have questions about that, feel free to ask. Tabular method for integration by parts. I don't know what my method's called. I just do it. But it probably isn't tabular method if I just sort of do it, I guess, the classic way. I wonder if it is 1 on lambda. Merrick, I think you got a pretty good idea. Because I do think that's going to be the answer just looking at the question. But let's get into our integration by parts. We're going to begin. Let's make sure my pen works. We're going to begin with an integration by parts question. Any integration by parts question, I have always done this very classically using sort of the classic formula. The integral of uv dash is equal to uv minus the integral of u dash v dx. Okay, that is sort of the formula that I tend to teach because it's very easy to derive and it makes sense. Wow, thank you very much, Abby, for sharing the live like 75,000 times. Thank you, James, for sharing as well. So that's my formula for integration by parts. I need to basically establish which parts are u and which parts are v. If I look at my function here, I've got two parts of my function. I've got the x and I've got lambda x e to the x, or e to the negative lambda x. So sometimes it can be a bit of a choice as to which bits do I make u versus which bits I make v dash. There is like a bit of a hierarchy. I know people have shared this. You can find it in textbooks as well. Thank you, James, for sharing the live as well. Yeah, so like I said, I guess typically like top of the pyramid, like one of the easiest things that we could do are exponential functions for what we determine or what we give the value of v dash to. So I'm going to say that v dash in this case is going to be equal to lambda e to the negative lambda x. And I'm going to say u is equal to simply just x. It's so easy to differentiate x that it's such a nice thing to get, okay? So I'm going to change my color to pink because pink's the best color. If I differentiate u, I'm going to get the answer of 1. And if I integrate v dash to get to v, well, when I'm integrating an exponential function, I divide, I should say, by the derivative of the function sort of in the top part of the power of my Euler's number. This is on an iPad, yes. Thank you very much for the rose. I have methods. Oh, yeah, tomorrow? Yeah, good luck. Good luck. Look, we can do methods questions too, Cavs. If you have methods questions, feel free. Thank you very much, boy, for sharing the live. Thank you, Adrian, as well. Yeah, iPads. iPads are great. So, like I said, if we integrate, we divide by the derivative of my function at the top. That is going to mean I divide by negative, and the negative part's important here, negative lambda. So I have lambda divided by negative lambda. A positive divided by a negative gives a negative. The lambdas cancel out, and I'm left with e to the minus lambda x, right? That part of my function is going to stay the same. So, I'm going to do a quick recap. Make sure we can see everything there. I have an integration by parts question. But it's not just integration by parts. I'm given the formula or a formula for the expected value, which is a concept that comes from statistics. It's a little bit of a bait. We don't really need to worry too much about the e to the x part of this question. We simply just need to use our integration by parts. I assign what's going to be u, what's going to be v dash. Again, if we can pick, and we can always pick, I like to make v dash lambda e to the negative lambda x. And I like to make u x. So, guys, my wife has brought me a tub of ice cream.
Please.
And a spoon. And a bowl. So, do you want me to serve this for you?
I need help. It's too
You can't.
hard.
The ice cream's too hard. I'm going to be honest, this ice cream, rock solid. Like, it's actually rock solid. Honestly, you know the worst bit, kids? I was setting up to clip this whole thing
Oh,
as a
sorry.
video, and now I've been interrupted by ice cream, but it's fine. So,
Can I please have it though?
I don't even know, honestly. I think I need a jackhammer to get into this. I actually don't need a jackhammer to get into this, but I did bend the spoon. I'd like to apologize. She is very nice. Yeah, it's a pretty random look. This is terrible because it's so hard. Like your hands slide down the spoon. This is like a vegan ice cream because my wife gets really worried. But she can't quit ice cream. Worried about health. Okay, listen. No, sir, you're very strong. Thank you. Thank you. Boil water, rest the spoon, and then gently. Yeah, Joe, I actually, when I have to do this, is I just chuck this thing in the microwave for 10 seconds.
No, you don't.
I do, every time.
Why?
I actually do. It softens it up a bit. That's why it's always melting around the sides when you get it. Yeah, Eli is a genius. Alright. Is this method, Sean? No, this is specialist, hence why it's integration by parts. Sorry, everyone. I'm just stuck trying to get ice cream out of a tub. Hope you guys enjoyed the delay. Bit of a brain break. Oh my god, it's so cold. That's as much as I'm gonna be able to do before my hands turn numb and fall off. Yeah, specialist maths. Specialist maths. So if you're someone who has your mocks coming up soon, or your, I don't know, what different schools have different names for it, mocks, trials, whatever you want to call it. If you have that coming up soon, then this should be pretty helpful. So do I do methods? Yeah, I did methods on the last live, Sean. So if you have methods questions, then feel free to follow along, right? I've done like 3 methods lives in a row, so it felt like it was time to do specialist. Thank you very much for the #1 gifted badge, Sienna. Hi, bro. Didn't see you for a long time. How often do you stream? I do stream pretty often, but I've had a pretty busy week. I will have a pretty busy week going forward because I'm moving house soon. So I stream as often, really, as time allows, to be honest. I would say normally I'm 4 times a week, but last week I think I was 3. But then I had like a week off. I did like 3 days in a row, and I've kind of taken a week or 6 days off. Is this year 10? No, this is year 12 specialist maths. But again, if you have year 10 questions or any maths questions, feel free to ask. I can try to answer them. I'll do my best to answer them at least. So, to get back to the question before we're interrupted by my wife wanting me to serve her ice cream, can I do year 8 math? Probably. If you have specific questions, like I said, feel free to ask. Year 8 math normally takes me about 3 seconds to explain. So, not because year 8's necessarily easy, it just tends to be a bit quicker. So, integration by parts. Get my formula, establish my u, establish my v dash, integrate the v dash, differentiate the u. I get my new sort of bits here. Now I put all these parts back into my formula. So that means I'm going to get the integral from 0 to infinity of x lambda e to the negative lambda x dx is equal to u times v. So I'm going to be multiplying these 2 parts here together. Okay, multiply these 2 parts together. I actually normally draw the arrows like this. I'm just going to draw it how I normally would, right? We multiply u and x. Or u and v, sorry. We multiply u and v together, and I'm going to wind up with negative x e to the negative lambda x. Okay, that's the first bit we're going to do. I can zoom in here, which is kind of nice. Actually, even better, I can grab everything inside a lasso, and I can shrink it down slightly. That way, everything can fit, and it looks nice and neat. So, I've got the first part. That's u multiplied by v. I'm now going to do, can you do hypergeometric questions? I mean, we actually did do some like geometric stuff here with the vector equations of planes and things just before this, but if you have any questions, like I said, I can flick back. Is this Calc 1 or 2? This is specialist maths from Queensland, so I don't know how you're going to break up the subtopics. This is like your advanced integration. What ATAR did I get? I'm going to be honest, guys. I know I might look young, but I graduated in 2014, so I don't even remember at this point. That goes to show how much it mattered to me. So, I'm now going to subtract by the derivative of u dash v. Or the integral, sorry, of u dash v. So I'm going to integrate. I don't know why I went back to blue. I'm going to get my colors correct here. I feel like I need an orange. I mean, maybe I'm going to swap out my pink for like an orange. But I guess I'm going to write this part all in green. I'm going to subtract by the integral of u dash v. U dash is 1 in this case, right? So now I kind of do this. This is sort of how I draw my arrows. We kind of go across. Ooh, let me go down towards the left. So I get 1 times negative e to the x. Because I have a negative, I can bring that negative all the way out the front, make it a plus. Then I can simply just do e to the negative lambda x dx. Okay, and I've now simplified my question quite a bit in terms of my second stage to my integral. I'm writing in a different language. Help. Yeah, listen. Depends on what maths you're in, right? And if you've done specialist, this isn't too bad. So I guess that all depends. What degree did you... I have an engineering degree, and then I went into education. Or at least I did most of an engineering degree and then went into education. That's what I did. So, if we fix everything up, I just feel like the green looks wrong. I don't know if we agree with that. I'm going to go to a darker green. I feel like that's going to look better to my eyes. A darker green I think is going to work better. Okay, so we got negative x e to the negative lambda x. I'm now adding the integral of e to the x. Again, we did this before. We divide by the derivative of the function at the top. So I'm going to get this kind of negative 1 over lambda e to the negative lambda x, and then now is the perfect... Oh, actually, wait, it's a definite integral. Sorry, I was going to add plus c. It is a definite integral. So at this point, really, I need to put everything inside my big square brackets. And I should have put them on this part here as well, from 0 to infinity. That's my bad. Put my big square brackets. 0 to infinity goes around those brackets, and now I can kind of do my substitute in part. Hi, Jack. Like I said, James, I did engineering into education with majors in physics and mathematics, but I prefer teaching physics. I went to a university on the Gold Coast. I do standard maths. What is this? Yeah. This definitely seems scary if you've never seen it before. This feels hard. Honestly, this is my favorite type of maths, to be honest, because it looks difficult. You feel very smart doing it. It's actually kind of easy. So I now just substitute in infinity and 0. Now, how do you sub in infinity? That's a whole different question. How do you substitute infinity into a problem? Well, this is relatively, in quotation marks, relatively simple-ish. Where really, like, this is very, like, number theory ways to solve our problems. If I put infinity into x here, right? I put an x out the front, so I've multiplied by infinity, which means everything goes to infinity. But I specifically put it into the power on Euler's number on my exponential. Okay? Do you have to use limits? You basically are using the concept of limits. You're not required to write them for full marks. But yeah, we're basically like theorizing limits. If I put a negative in here, okay? If we just consider what happens, I'll do a little example. I'm going to erase it, but I'll do a little example. If I have, we'll just look at the e part. That's the bit that matters, right? I got e to the negative infinity multiplied by lambda. If we know anything about indices, and we know that negative powers go on the bottom, so I basically get 1 over e to the power of infinity multiplied by some constant. If I divide by a number approaching infinity, if I divide by a bigger and 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 bigger number, I wind up with something that approaches 0. I want something that approaches 0. So this whole idea here basically trends, if I could do limits, right, I trend towards 0. So I can effectively say, okay, well, that's going to be, if I put infinity into my first term, I get 0. Well, if I look at my second term, I have the exact same thing happening. And again, I have a power of negative infinity. So again, it's going to approach 0 as well. Okay, so the first two terms, 0 and 0. Now, to finish off my definite integral, I'm going to subtract by, and now substitute 0 into the problem. You might think, well, when you put 0 in, you're going to get the same issue. Well, when I put 0 in, so the first term here, I get 0 times e to the power of 0. Yes, that disappears, that goes to 0. So the first term also is going to be 0. But the second term, I'm only putting 0 into the indice. I'm late to class. Please tell me. What? You're late to what class? I'd like to reply to you, star, smile, star, but I don't know what your question was. I'm sorry, I can't see it anywhere. That was in my sack, yeah. Yeah, similar type of questions. Can I have some ice cream? Unfortunately not. That would require teleportation. Infinity times 0 is indeterminate too, isn't it? Yeah, like for this question, we trend towards 0, so we can leave the answer as 0. Got my spec mock tomorrow. Well then, Suey Dewey, you're in the perfect place if you got your spec mock tomorrow. What's this doing on my For You page? Maybe it says you got a good algorithm, Pineapple. Maybe it means that, you engage with good content. So, that's not a 10. I need to make it look a little bit better. This is going to simply be 0. Whoa. What the heck? What the heck is going on? No thanks. So, I'm just going to fix up my bracket. I've got a big bracket here. If I put 0 in, I wind up with negative, specifically, I wind up with negative 1 over lambda multiplied by e to the power of 0. E to the power of 0 is 1. Anything to the power of 0 is 1. So what ends up happening is I literally get negative lambda times 1. That just gives negative lambda. I've got my negative out the front, right? Bracket expansion, 2 negatives, all that business. It's going to become positive. And I wind up with a pretty simple answer of just 1 over lambda, all positive. That's the final solution. I'll get rid of this bit here because it looks like it's part of the question, but it isn't. That was just me simply explaining what is going on. So honestly, look, it's meant to be simple, familiar. It's question 13, right? This is the third simple, familiar question in the exam. So hey, like, it shouldn't have been too bad, but there's a lot of theory to get full marks here. I appreciate the maths that looks mind-boggling. I appreciate maths that looks mind-boggling as well, Pineapple. I'm a little rusty on Gaussian elimination. Like, I swear I'm doing the right stuff, but I'm just not getting it, is what I assume you're trying to say. Got SOR tomorrow. Listen, I could not help you with SOR. Good luck to you. Look, we can do some Gaussian stuff, right? Like, yeah, we could do Gaussians. We could do Gaussian, so we do it. I would say, hello SVL Zeus. I would say, appreciate that maths isn't 1 + 1. Yeah, true. Actually, maths is like 75 answers. Everyone that says, I like math, has got one answer. They haven't done hard enough maths. So, yeah, look, we did some stuff. That's not really Gaussian, I guess, right? Like, that's just normal vector work. Is there a Gaussian question in the 2020? Let's have a look. No Gaussian, no Gaussian. Whoa, hang on. That looks kind of fun. All right. Ooh, okay. Actually, some pretty... Oh, nice. There's actually some pretty good questions in here. And we have volumes of revolutions of a solid. Volume of solids of revolution. I always mess up pronouncing that. That looks like the final question. Listen, Suidui, if you've got a Gaussian question, I can make a Gaussian question. Yeah, it should be tech-free. Like, I mean, there's tech-active ideas around it, but normally it could be tech-free. We can do some Gaussian at the end if you stick around. Can you upload that document somewhere? What, my solutions or this actual exam paper? Because this exam paper is free for anyone on the QCAA website. You can just get that from the QCAA Specialist Maths Past Papers 2020. Bam, you have it. Okay, do you enjoy maths? I kind of do enjoy maths. I'm failing general math year 11. That's okay, right? That's okay. There's so many reasons why people struggle in maths. It's not all you. All right, so look, that's pretty chill. That's pretty chill. Okay. We're gonna do question 14. I feel like I need water a little bit. If my wife happens to be listening to the live, if I could get some water, we'll see if she will. So I've got a projectile motion question. So I've got an object moves in a straight line. It's given by oh my god, inverse trig function. Arc cos, as some people call it. Determine acceleration, where acceleration is meters per second of the object. Okay, so I need to read the question a little bit. These motion questions are a little rusty. The motion of an object moves in a straight line given by that. So we got velocity. We determine acceleration. Okay, well, I basically just need to know that to get from velocity to acceleration, I have to differentiate. The issue with this question here specifically is that normally when I do this, okay, wait, let me just quickly have a look. Is there eigenvalues in spec? Not really. I think they're introducing some ideas around it, but not really at this stage. You don't need to, at least it's not very deep. I like your mustache. Dude, I don't know what's going on with this. I'd like to clarify, Harry. This isn't an intentional decision. I just can't find my razor at the moment, and it is what it is. So, seems like IA3. Is there an external past paper for IA3? I think there might be a sample on the QCAA website for IA3, but I'd say your teachers are going to be the best people to support you with that. So I'd check them if they've got past papers. So trig proofs, is that not what's coming up? Like, I think we literally have a proof by mathematical induction with a bunch of trig. But if you want to do specifically, like, I mean, I can throw some random examples on there too. I mean, I can throw, like, any questions, to be frank. All right, so the issue with this question is normally, I guess this is the important thing to realize, okay? I'm going to bring my pink back. My pink pen, because you know, I fought hard to get a pink pen. Normally when I get velocity, it's in terms of time, okay? So if I get velocity in terms of time, I differentiate. I get acceleration in terms of time. The issue I have here is I want to get acceleration in terms of x, and I'm given velocity in terms of x. So I can't do just the standard differentiate, bang, happy days. Instead, I need to have a little bit more theory about, and this is on the formula sheet too, right? And a little bit more theory about what is going on with velocity equation expressed in terms of position. That's the key bit, right? X is my position. So I'm expressing velocity not in terms of time taken, but in terms of its location, which can change. Yeah, I tend to wear glasses when I'm doing a lot of things on, like, computers or reading, because my eyes get tired and they start to hurt a little bit. I'm in uni and I hated this in high school. Yeah, I kind of like motion questions, but I did do physics and maths for majors, so, like, you know, it kind of makes sense. Alright, so, I need to know that my acceleration, if I'm doing it in terms of position, is equal to my velocity multiplied by the derivative of my velocity with respect to position, which is all kind of like a relatively straightforward-ish way of saying I need to differentiate it once and then multiply by v again. That's basically what it says. Differentiate it, then multiply by v. So if I differentiate it, I'm going to start by finding dv dx, okay? And you can do this in many ways, but I'm going to start by finding dv dx. I want to differentiate specifically. I'm going to rewrite that in case you guys can't quite see it. I want to differentiate cosine to the -1 of 2x, okay? That's what I'm differentiating. So if I'm differentiating a arc cosine function, I have a formula, right? I want to use my formula sheet. My formula sheet tells me specifically that it is -1 over the square root of brain 1 over a squared. So 1 over a squared. Yeah, 1 over a squared minus x squared in this case. So what I'm going to wind up with is -1. Whoa, that's the wrong color. -1. I don't have the formula sheet here, so if I somehow made an error, like part of my brain is like when you're talking a lot, it's buffering. But I'm pretty sure I'm right. Right, 1 over a squared makes sense, right? I get 1 over 4. 1 over 4 minus x squared. I probably don't really need the brackets now that I've written them. I probably can just get rid of my brackets. It's fine. So that's going to be my derivative. That is my dvdx. Once I've got my dvdx, wait, stop yapping. I'm yapping too much about maths. I feel like I need to quickly check. Did you do a mathematics degree? Not a pure maths degree, no, but I think if I do like 3 more units, I technically have one. Should I move schools and do specialists or stay and do normal maths? I don't know, Andy. I don't know. I think specialist is fantastic. Is the stuff I have to do next year? This specialist is stuff I have to do next year, but honestly, none of it's too difficult. I think year 11 is harder than year 8. Where did the 1 quarter come from? It came from... Oh, hi, basketball. Welcome back. I don't know my formula sheet. I don't know my formula sheet. On the formula sheet, unless I've misremembered, the formula sheet says that the derivative... I'll do it in pink. The derivative with respect to x of cosine to the -1 of... I understand what it is now. Sorry, it's like this, isn't it? It's x over a. It's x over a. I kind of knew I was right, but I was like, I felt like I was messing something up. It's that, right? Am I wrong? Correct me if I'm wrong with the formula sheet. I'm pretty sure that's it. So that's my formula. The derivative of that is equal to -1, that's where the negative comes from, over the square root of a squared minus x squared. The issue is I've got a 2 out the front, so I actually get like a half. Like 2 is the same thing as having a value over half, so I basically square that and I get a quarter, and that's where we're going. Okay, hang on. I feel there's a lot happening in the chat right now. I did my degree in discrete maths and operations research. Wow, great job. That's awesome. I need your help for linear relations. Right, linear relationships. Yeah, we could talk about that. Yeah, like right now there's a lot of external exams coming on. After that, I feel like I could do some lower set content. Did I do physics in high school? I did. It's really embarrassing to say. One of my favorite subjects, personally. I originally wanted to be a physics teacher. Then I taught maths and realized that maths is goated. But up to that point, I wanted to do physics. Yeah, discrete maths is great. So, like, what type of fade? Okay, I feel like I'm missing something there, but that's okay. Interesting. Just at my last special. So when you're saying SAC, is that your way of saying trials? Or is that what you, like... Because people have said this term a lot. I feel like I never used that at my school. Year 11 physics is going to be the end of me. Year 11 is probably the hardest year in high school, though. Like, no cap. I assume it's like mock, right? But yeah, sorry, basketball. Does that explain where the formula comes from? Because if that does, then we're here. Basically, it's over 2, so I can rewrite that as being cosine to the -1 of x over 1 over 2, because like if you divide by a half, it's 2. You kind of flip it. It comes up the top. Square it. You get your quarter. So, once we're here, we're now multiplying by v. If we're going to multiply by v, that is my, well, it's vx. It's my original function. I wind up with my acceleration, in terms of x, is equal to cosine to the -1 of 2x. I can put all this on top. I'm just going to write it like this just to make sure we're all on the same page and we're all learning. I get that, okay? Now I can fix this pretty easily. Like, I'm multiplying, right? It's multiplying 2 fractions. I just multiply top line, bottom line, and I'm going to wind up with, if I get rid of my pink stuff here and I shrink it, or maybe I'll leave that and I'll shrink everything down. I'm going to shrink everything down so I can actually write my final answer. I only need a little bit of space, right? We've got the solution. We should be able to see the solution. It is simply, well, that's the wrong pencil. That's still pink. That's blue. It is simply going to be my acceleration in terms of position is equal to negative cosine, to the -1, 2x over the square root of a quarter minus x squared. Not too bad. Just had year 11, methods year 11. Oh, congratulations. That's nearly done. I think I got like 10% of my mocks. Yeah, the mocks are really difficult. 2 + 2 = 4. Is every state doing mocks right now? Pretty much, I'd say every state's doing mocks right now. So that's why, you know, maths will never escape you. Yeah. Am I from Melbourne? I'm not from Melbourne. Or someone's... Me? Tom? Actually, no, I'm not from Melbourne. Bro, I have... Tim, someone needs to explain what SAC means. SAC. It's mocks, I assume, right? Next week on hypothesis intervals and Z scores help. Yeah, listen, hypothesis intervals. It's been too long since I've done that. It's not something I've got to. I've done in a while. You became a maths and physics teacher. I certainly did. Got chem and physics on the same day. That is actually brutal. I feel for your basketball. That's pretty rough. My school wanted to do different and do it a week early. Oh, that's nice. Is it true that specialist is really hard? Because I'm currently doing year 11 methods in Melbourne. I would say that specialist is difficult. There's so many things that can make it manageable. Good teaching. I'm not going to lie, I think that makes such a big difference, right? And having some good, like, science of learning theories, I think, help around explicit teaching helps a lot. I think if you can get through year 11, year 12 is easier. And you might need, or you might find, that tutors can help, especially in Melbourne where it's so competitive. So, let's do part B. Can I do a CU probability, please? We got volumes of solids. Yeah, like I can. I 100% can. I don't know if I'll get to it in this particular live because it's already getting late-ish. Am I in Queensland? This is a Queensland paper. I have taught in Queensland the last 4 years, currently teaching in New South Wales. Oh my gosh, I got maths prelim on Friday. I'm so glad I stumbled upon you. Oh, you're welcome, fictional. So, proofs, transformations, matrices, circle proofs, imaginary numbers, and absolute graphing. Proofs is kind of alright. Is this the content? That's a good summary. Okay, fine rounding hard, then... listen, that's a tough break. Is this QCAA 2020? Yeah, it is QCAA 2020. Alright, so I want to use my results from part A to determine my acceleration when x is 0. My initial position is some ways to think of this, like, typically, right? Not always, but, like, it's an application that has similar parallels. Position, or accelerations between -2 pi to 0. So, I simply am going to sub in 0. There's nothing too crazy here. I put 0 in place of my x values. I get negative cosine to the -1 of 0, which we should hopefully know. Hopefully we know. Cosine 0, we're finding the angle. Like cosine 0 equals 1, so cosine, like arc cosine, like if I get an answer of 0, I get pi on 2. The words struggled to come out, but hopefully that made sense. I can re-explain if people don't understand what that means. So I go live every day. Not every day. Like I said, normally aim for 4 times a week. It just depends. I have a busy life in many ways. So QCAA 2020 was actually insane for every subject. Yeah, I think it's difficult because it's the first one out too, and people didn't really know. Please re-explain, please. Okay, so cosine to the -1 finds the angle I need to get an answer of 0. So the angle to get an answer of 0, if we remember anything about the unit circle, or even if we understand like the basic graph of a cosine function, we get something like this. We should know that the 0 point is at pi on 2. Okay, or unit circle people, it is here, it's on the y-axis, right? Because sine is x and... So cosine is x. So on the y-axis, my x value equals 0. So therefore, if I get a situation where I'm doing cosine to the -1 of 0, then I need to, don't have a choice, I need to know some basic values. I need to know that equals pi on 2. Okay, I've got a negative out the front, so it's going to become negative pi on 2. I'm jumping the gun a little bit. I should look at my denominator as well. My denominator is a little bit more straightforward. It is simply the square root. Don't know why it's become green. We're going to roll with it, though. I feel like it helps split the question up. It's going to be 0 squared. So all I get, basically, all I'm going to wind up with here is I know that this is going to be pi on 2. I have the negative out the front. That's going to stay negative down there. That's where the negative comes from. Okay? During my friend's methods test, the fire alarm went off. That's brutal. I'm going to divide that by the square root of a quarter. The square root of a quarter, well, the square root of 1 is 1. The square root of 4 is 2. So I get a half. I can now keep, change, flip. And I'm going to wind up with an answer that is negative pi on 2 times 2, which is just going to be negative pi meters per second. Oh, sorry, it's acceleration. Meters per second, or meters per second to the -2. Should I study for my maths test? Isaac, yes. Yeah, of course you should. A squared plus B squared equals C squared. That's great. Tane, Sonny? I'm sorry if I pronounced your name wrong. Are you in a closet right now? I'm actually not. But this room is really weirdly designed. I have this kind of sliding door that goes into another room, actually. There's a room behind me. And, yeah, I'm not in a closet, basically. That's probably the easiest way to explain what's going on. Wow, I'm really... Why did you say that, Calvin? That doesn't mean you are. What are you trying to calculate? I calculated already, so I'm not really trying to calculate anything. I did it, but is there a question about this? Trig proofs and identities. Yeah, I don't know if you're calling me Unk. Is that Unk? Algebraic topology next? Or is UNC a thing? Are you a teacher or what? Yeah, I'm a teacher, Miles. I enjoy circular function. Yeah, fair enough. What did you get on your ATAR? That's a weirdly popular question. I graduated in 2014. Like, I'm 28. Like, I don't know. My ATAR was a long time ago. It's so different now. ATAR didn't exist in Queensland when I finished high school. So, question 15. Wait, I should actually look at question 15. We got a plane. 3 dimensions. We got a plane. Origin, A, C. Okay. Atomic coordinates of B. Ooh, okay. Wait, I need to... We have time for one more question, probably. But I really need a drink of water. Wait. Can I... Hang on. Should I shout? I don't want to be really loud, am I? I'll be fine. It's fine. It's fine. Okay, so I'm just gonna weather the storm a little bit parched. I'll just get through it. So, awesome. I'm just gonna keep going. So, I've got 3 points really. I got a lot of points, but I've got my 3-dimensional space object. Okay, so my object in 3-dimensional space. I'm trying to figure out the coordinates of B. B is this point here. So I'm trying to figure out my 3 coordinate points because it's 3D, right? X, Y, Z. I'm trying to figure out my 3 coordinate points for part B. Okay, so if I want to figure out my coordinate points for B, then I'm simply going to go from, well, I got a few ways, right? But just with the information I'm given, okay, with the information I'm given, I want to find O to B. So I'm trying to find, wait, I can draw a straight line here, I'm pretty sure. Let me get my pen out. Aha! I want to go from here to here. Okay, I want to find OB. That's basically what this question wants me to do. Or the easiest way to get it is to go from O to B. So to go from O to B, I got a few different ideas of how I could get there. I could simply go from O to A. Wait, where's my pen? Where's my pen? Here we go. That's a bit wobbly, but luckily I've got magic and it's going to straighten up. So I'm going to go from O to A. We go to here. Boop. And I know, because it's, well, it's essentially, it's vectors, right? I can also add in, because, like, I can reshuffle, right? I got a vector here. Actually, I'll literally grab it and show you guys what I mean. I got a vector here, okay? I can do this really cool thing where I go, okay, I can find O to C, but we can add vectors however we like. It's sort of this hidden vector thing that you may or may not be aware of. We can add vectors sort of however we like. We can essentially start them in any location. We just tend to choose nice ones around the origin. So I can just put this one here. That's fine. And then suddenly I go from O to A, I go from A to B. To get from A to B, it's the same as going from O to C. Now that has confused many students, okay? I can explain that more, but this is what I'm doing. I'm basically, if I find OC, I'm given a vector that describes a direction, meaning a vector that describes a magnitude, a length. I can technically pick that vector up that has that direction and that magnitude. I can put it anywhere. Well, I know that exact distance, because it's a quadrilateral, is going to be this distance here. Okay? I want to see if anyone in the chat is following this. Am I in New South Wales? Right now I'm in New South Wales, yes, but I have taught in Queensland. Yeah. Okay, I don't think it's anything. If anyone's got a question that, like, I missed and they're upset about it, rewrite it in, sorry. So, to find O to B, I'm simply going to do O to A plus O to C. Well, I know OA, I'm going to write it as a column vector, is -6 to -2. And I know that OC, as a column vector, is 3, 1, 2. I can add these sets of coordinate points together. If I add my x coordinates, I get -6 plus 3, I get -3. I get 2 plus 1, I get +3. I get -2 plus 2, I'm going to wind up with 0. So I now know my coordinate points for B, specifically in this case, right? My coordinate points are going to be, -330. I'm just thinking for a sec. Interesting. That seems legit. It seems legit, right? The zeros kind of throw me a little bit, but I guess it's flat. It's not to scale. It does say that there. So maybe I'm just not going to overthink it. The maths is mathing. It is mathing, I promise. So, thought all schools are off criteria. Do you upload on YouTube? Actually, okay. I'm going to answer your question. There's like guideline stuff. I'm going to answer your question and say, yes, this whole thing actually will be there. So, oh, hi fam. Welcome back. Okay, so, do you do trig and specialist and methods? Yes, you do trig and specialist and methods. So, now I want to determine my vector representing OM. And it's really important to know that and you can actually see visually when I draw it, right? I pass through vector n. Is that relevant? Maybe it's not that relevant. Let me think. I want to determine the vector that represents O to M. So I'm trying to determine the vector that goes from O to M. Let me... Oh, hang on. Wait. I need to think about this a little bit. I feel like... Am I missing information on this question? Oh, I am missing information on this question. That's pretty important. M's the midpoint, by the way, everyone. M's the midpoint. So, if you didn't read that, that's going to be an issue. Hello. Okay. Wanted to ask, when you deal with norm questions and the question involves weight, normal distribution questions and the question involves weight, would you put negative infinity as your bounds? Oh, these are such a good question. And I've always had an answer for this, right? You can't have negative weight, so why go to negative infinity? There is something around the idea of like, for a normal distribution, right? We say it goes from minus infinity to positive infinity. But that doesn't, it doesn't necessarily represent the measurement taken in a sample. Does that make sense? Like, because it's a theoretical concept where it approaches something. I think essentially, in most cases, it doesn't matter. If you put minus infinity, I think you get the same as if you put 0. I know there's some questions where I've thought it has mattered and it didn't, and there's some where it doesn't. I can touch up on that. Teacher says it's a model. Yeah. Yeah, like your normal distribution going from minus infinity to positive infinity, it doesn't necessarily have to be like the score is negative infinity, if that makes sense, right? Like it's just sort of an approximation that gives an area of 1 if you differentiate the entire curve between those two boundaries. So I think normally you're fine to negative infinity. Thank you, this helps you so much. I'll be ready for year 12 and year 7. Yeah, well, to be fair, if you follow along for the next 6 years, you're going to have seen every external paper basically. So yeah, you'll be pretty ready actually if you're keeping up. Am I Kiwi? No, I'm Australian. My wife is from the UK, so she has an accent, and sometimes that affects my accent. What was your score on mathematical methods? I am too old for mathematical methods. That didn't exist for me. So I can't tell you, but I have taught students that have got 100, just full marks total, and I've also taught people that have come first in the entire state. Am I in Queensland? Not currently. Not currently in Queensland. Have taught in Queensland in the last 4 years, though. So if M is the midpoint, we'll finish this question real quick, then I'll answer more questions. If M is the midpoint, then it's the midpoint between these two coordinates specifically. It's the midpoint between B and it's the midpoint between C. I can actually do this using some, literally, for people that want junior maths, this is some year 9 maths. Honestly, teachers to in year 8, we have a midpoint formula. We can actually use midpoint formula. We can you can kind of cheat the answer a little bit here, actually. We don't have to do anything too crazy. There's some stuff around vectors and all that. I'm going to here. We can circumvent all of that by, if we remember, the good old-fashioned midpoint formula. The midpoint formula is the average between your x coordinates. So I add the two x coordinates together. I call it x1 and x2, but it's just add the two x coordinates together, divide by 2. Add your y coordinates together and divide by 2. And guess what? If you've never seen it with 3 coordinate points, it also works for 3 coordinate points as well. And you divide by 2 again. So it's 1 mark. So, like, get the answer. This is the way to get the answer. If I add my x coordinates, I know that my x coordinate for B is negative 3. And without having to rewrite it, this whole coordinate point here is 7. I'm just going to use my highlighter. So I'm basically adding 3 and 3 together, right? Well, minus 3 plus 3. I'll just write the whole thing. Minus 3 plus 3 over 2. And that's going to become for my y coordinates, that is 3 plus 1 over 2. And for my z coordinates, that is 0 plus 2 over 2. I now got my answers. Well, minus 3 plus 3 gives 0. So I'm going to get 0. I'm going to wind up with 4 over 2. Yeah, 4 over 2, that's going to give 2. And I'm going to wind up with 2 over 2, which is going to give 1. So therefore, I'm going to write off the page a little bit. It actually says specifically, hang on. Do not write outside this box. Well, look at me now. So, specifically, OM is going to be equal to, zoom out a little bit, 0, 2, 1. If I write that as a very, very small column vector, and I try to hold my... This is why I can't write in the box. It's actually not within the realms of possibility to be seen. Does that make sense? Is that my answer? Oh my god. My throat is killing me. Okay. Oh, I said this was going to be the last question, but we actually are still going. Determine the vector that corresponds to ON. Interesting. We have a ratio. Ratios. N divides AM in the ratio of 2 to 1. Again, people that wanted lower level content, welcome to ratios. Okay, this is year 8 right here. Can you get 100 ATAR? You can't get 100 ATAR. The highest ATAR possible is 99.95. Look, I've certainly taught students that have achieved that. Do we do complex number locusts? We do complex number locusts. 100% we do. We do it here. We do it here on the channel. We do it here in our exams. I've got a bunch of great questions. I've written some myself that have done things. So kind of like that particular area. Is this Nessa? No, this is QCAA. I did this in primary school. Dividing ratios. Heck yeah. Isn't 2/3 of a vector. Okay, so I got 3 parts total, right? I got 2 to 1. I got 3 parts total. That means that if I break it up, okay, if I break it up, I've got AN is going to be equal to 2/3 of AM. And the other remaining third is from N to M. That's going to equal 1/3 of the vector AM. Okay, the whole thing being AM. So I want to determine the vector that represents on. So if I go from O to N, that is simply going to be equal to OA. Maybe I should get the picture back so we can see. And I'll get rid of some of these lines so we can just see for the new question what all this means. Okay. Okay, so we are determining from O to N. So we're trying to get, basically, I'll draw the vector we're trying to achieve. I think, honestly, with vectors, drawing it out can help. From O to N. So we're only given this concept around A to M. So we're trying to go from, I'll use pink, because again, best color, right? If anyone wants to be an interior designer, if I interior design things, whoa, look at that magic. It was so wiggly, but it came right. If I was an interior designer, everything would be pink. That's just, I think it's the best color for interior design. I feel really passionate about that too. That's why I'm actually okay to say that on a public forum like this, because I feel so strongly about it that all right, we're doing that. We're going OA, A to N. That's basically the idea. So we're going OA plus A to N, and I know from above, hey, A to N is 2/3 AM. So I can substitute that in. I get O to A plus 2/3 A to M. And now it's kind of achievable, right? I can find AM. I guess that's the thing I don't actually have now I'm thinking about it, right? AM is going to be, I guess it's going to be sort of a similar idea to what we did before. Oh, wait, I found OM already. So it's literally just going to be, AM is going to be, what? OM? Hang on. Why is my brain buffering? O to M? Oh, okay, sorry. AM, yeah, okay, there's like a rearranged thing. So sorry. Listen, hey, sometimes we can all have mind blanks. I'm part of the 0.05. Congratulations, not so sure so. So, basically, I'm gonna draw it out like this. I'm just gonna grab these pictures and I'm gonna pull them off to the side. That way we can figure out what's going on. Okay. Content outside of page. Yeah, I'd love to undo that. I didn't mean to do that. Sorry, everyone. We'll go here. So basically, I know how to go from O to M. That's a bit curvy, but that's okay. And I can go from A to M, and that is equal to A to O. Now I can kind of like reverse this process, and I can get the answer I'm looking for. Okay. So basically, what I'm going to wind up with is OA, O to A. Oh, sorry, I've got my straight lines on, which I'm so messy. Even straight lines doesn't save me sometimes. Get my pen back. I'm going to go from O to A plus 2/3 outside of. I guess probably the easiest way to write this is kind of like how I did it just before, right? We go from O to M, and because we're sort of doing a rearrangement, minus O to A, because I'm basically like flipping it back around and trying to get the point. So if I do that, like rearrange OA plus that equals that, so I can swap. I think that's the best way to explain it with the hand gestures. I think everyone, how can we possibly be confused, right? So now I can put all my stuff in. I'm going to wind up with OA. I can expand. I probably don't have to expand, but I'm going to expand. I'm going to say, yeah, this is a section where, you know what, if you do it a little bit differently and you still get the right answer. If I put all of that in, oh, actually, wait, this is a great idea, expanding. I didn't realize how clever this was until I stopped and thought. I got OA in 2 spots. I can subtract these two, right? I can literally do OA minus 2/3 OA, which means I wind up with making my life quite a bit easier. I actually get 1/3 OA, right? Because one whole lot of OA minus 2/3, but it gives me 1/3 left. And I'm going to add 2/3 of OM. And I can now just find both of these two things, right? We have all this information. There's going to be 1/3 outside of OA from before was minus 6, 2. Minus 2, there we go. Minus 6, 2, minus 2. And OM is 2/3 outside of OM we also just did is 0, 2, 1. 0, 2, 1. So they're my two vectors. I can multiply stuff in, add them all together, and just for the sake of saving time, right, we can add numbers together. I'm going to grab all of this. It's going to grab my arrow too, isn't it? Whatever. It's fine. Wait. To save myself some time, I can think this through, actually, right? I got a third times 6. That gives me 2. Oh, I get 2/3. We get 2/3 on the other side. Okay, I'm going to cut to the chase. We get minus 2. Unless I made a mistake. 2, 0. There we go. That's our answer. You can tell my voice is starting to hurt because I'm running out of steam here a little bit. Alright, is this year 11? No, this is year 12. This is year 12 specialist. Alright, final bit, surely. Final bit. Oh, I love induction, though. We can do a whole live just doing induction questions. Maybe we should do something like that. People need induction help. Because I feel like you just need to see a bunch of different tricks. Alright. Sore throat. Use a vector method to show O, B, and N lie in a straight line. Okay. So basically all I'm really proving is like parallel. Like I'm basically proving parallel concepts. Okay. Parallel concepts. So I've got what? I'm trying to prove that the... Oh, do you know what? So my brain went dot product, but dot product proves perpendicular. Dot product equals 0 proves perpendicular. This is a really weird idea that I don't know how often has come up for you guys in your lessons. But there is this idea, if we remember, right? This is like a vector concept idea. If I have cross product, not times, and that equals 0, I have parallel lines. The same is true for J cross J. If that equals 0, parallel lines. And the same is true for K cross K. If that is true, equals 0, I get parallel lines. So basically, all I'm trying to do is with the cross product of O to N, cross O to B, right? Yeah, O and yeah, because they're on the same straight line. If that equals 0, that's basically what I'm trying to prove, required to prove, right? RTP. If I can do that, then I've got everything's on the same line. I'm struggling so bad with induction. Honestly, so many people are. We will do, like, I love induction. We can do every single external exam induction question ever written, if you like. We can just do every single one. And you can even throw ones in that you like, because I like the struggle. Sam, what was my ATAR? I graduated in 2014. ATAR did not exist when I graduated. At least it didn't exist in Queensland. Other states did have ATAR. So, if I do my cross product here, I got my cross product. I got my I, my J, my K. I got my little, I'm going to write a very small plus, minus, plus at the top. And I've got my two vectors, right? ON, that is going to be minus 2, 2, 0. OB, that is minus 3, 3, 0. I'm now going to do my cross product, and we can see I've got zeros, right? I'm very likely to get a lot of zeros in this question. If I do my I parts, I need way more space. I need to grab all this and make it way smaller. Okay, if I do my I components, that is equal to, here's my little mini vectors, right? I got minus 2, 0, minus 3, 0. That's my I coefficient. Minus, if I do my J coefficients, I get minus 2, 0, minus... Wait, I messed something up there. Oh, yeah, I did say the same thing twice. Somehow I saw a 2 and I got thrown. That's 2 and that's 3. That is minus 2, minus 3, yes, and 0. That is for my J. And I'm going to add my K. That is going to be minus 2, 2, minus 3, 3K. I can already see the answer is going to be good, but let's just do it. 2 times 0 gives 0, plus 3 times 0, which gives 0, so I get 0i. Minus negative 2 times 0 gives 0, and again, I'm going to get 0 lots of J. Plus, I do negative 2 times 3, I get negative 6. I do 2 times negative 3, I get negative 6, but there's a minus in between. 2 negatives make a plus, and I get 0 lots of J. That was a quick-ish walkthrough, but that is my answer. Therefore, they're all in the straight line. And sleep mode, you can't see, but sleep mode is activated on my iPad, which is probably a sign. And my voice is dying slightly. Keeling, what do I do for work? I'm a maths teacher. Can you explain how to represent a prime number for induction proof? We can definitely try to do some questions like that. I've got this question in my mock today. It was like n to the power of p minus n is divisible by a prime number or something. Oh, that's interesting. I don't know. I have to think about that a little bit, actually. Like, what's the theory on a prime number? Only two factors, right? Is there a way to express that? I don't know if I've come across many prime number ones. I'll have to think about that, Trent. I'll see if I can find one. If you have the question, feel free to DM me the question. I think pictures work if you can send me a picture. All right. Well, that's maybe it for the live. This is a bit random. I have to actually do 50% gaming content. Otherwise, I get my live banned for 7 days. I can still go live. I just can't go live with the iPad, and you can see me, and I can wave and all that. And I kind of like these lives better. It feels better for me. So do I play video games? What, we went live for like 55 minutes. So I play video games for 55 minutes. I mean, that's like, how appealing is that? I don't know if that's that appealing for me. Can you do year 11 extension 1 question involving parametrics? I can. 100% can. There's parametric stuff in here too, but not this live. But feel free to follow. Come back in another one. I'll make sure I find the time. Yeah, the prime number one. It is interesting. I do agree the prime number thing being odd, but not odd. If that makes sense. All right, because 2's prime, it's even technically. You know, there's some things around that. So that's it for the maths part of the live. I'm going to quickly check with the boss, which is my wife, to see what the best way is. I'm gonna put it on Clash Royale. I'm not saying it is going to be Clash Royale. I know people will do sometimes request that. I'm putting on that because I feel like if I'm on the app, that is counting towards my minutes of gaming content, so I can try to do this again. But I also might just not stress and let it disappear into the wind too. And I'll come back in a week on this live. Otherwise, it'll be normal like pen and paper lives like I normally do. How hard can this year's spec QSAA exam be? I think it'll be the hardest one ever written, Alex. Sorry. I think it'll be the hardest one ever written. But you guys give me 1 second. I'm gonna be back. That's sort of a promise. Alright. Oh yeah. 3 fireballs. Things are looking up. Yeah. Alright. Is anyone still on this live? We're down to 15 people. I think we can call it. Okay, everyone. It's been real. Goodbye, all. Thank you for those that stuck around. Thank you for the 7.4k likes. I didn't really get to do a proper wrap-up on this, but people that are still around, thank you very much. I will see you guys all in the next live. Again, you know, hey, that's not what I did. We just finished off this question. We'll do some induction during the next one. Goodbye, everyone. Thank you so much for those that hung around. It's been fantastic. And like I said, I'll see you guys in another live. Goodbye, all. Goodbye, all. Yeah. Goodbye, everyone. Struggling to know where the end live button is. So we are trying to, in part, figure that out.